Electrolyte plating is nothing but without the power, without external DC current. Am I audible to everyone?
Yes, ma'am.
Okay. Without the electric external power supply, the coating of the plating or a coating of a metal on the surface of a polymer or conductors or semiconductors or anything, that is called as electroless plating. So this electroless plating involves only reagents, reducing agents, complexing agents, exaltants, stabilizers, additives, buffers, and electrolyte solutions. So why all these things, all the chemicals are acting as the reagents. With the help of all these chemical reagents, the coating has been done. So what is that first one? Electrolyte plating can be how to prepare the bath solution. But the bath solution is prepared by adding electroactive metal, which is a metal ionic solution, which is nothing but a electrolyte, which contains a main source of a metal, which where you want to coat that metal ion solution should be. It should contain a metal ionic solution, and the bath solution it should contain a reducing agent. What type of reducing agent? It should undergo reduction to reduce the metal ions into metal atoms. Like for example, in case of nickel, we use sodium hypophosphate. In case of copper, we use formaldehyde. We need a strong complexing agent where it has to complex between the metal ions and the coating, that is the substrate or a object. So this complexing agent may be EDTA we will use as a complexing agent. A good complexing agent, EDTA serves as a good complexing agent. And we need an accelerator. Accelerator means which boosts the reaction or which increases the rate of plating. That type of chemicals we need to add. They are called as accelerators. That is the type of reagents we are using. They are called as accelerators. And apart from, along with this, we also add stabilizers, which maintains the stability in the solution. We also add additives like brighteners. These are all, and also we add to maintain the pH, we add buffer. So this is by adding, depending on the type of coating, depending on the type of the solution, we add different reagents. By adding different reagents, we prepare the bath solution. So first process in your syllabus, what you have is electrolyte plating of nickel. So what is the objective of this electrolyte plating? The object is to impart the corrosion resistance property, to impart hardness of surface. So this is our objective. So what is electrolyte plating of nickel? We are coating a nickel from the electrolyte solution on the object. You can see here the picture here, what I am showing on the arrow mark. Here we have a different containers, different vessels, 1, 2, 3, 4. The first one contains here at the last, the first one, can you see I am marking? The first at the last which we contain, I'll just pass the slideshow. Yes, here you can see here this vessel, all the containers, all the different containers contains the nickel solutions. Okay, so but in different concentrations. First one we have to clean or degreasing or cleaning impurities. Second one with the pickling or reagents or each of the this is called as electrolytic bath temperature. This is the bath containers. This is the bath containers. Depends on the concentration of the nickel, we have to coat. This is how we have to prepare. How you have to prepare this bath solution, what it contains in the electrolyte plating of nickel. The bath solution contains nickel chloride, 200 grams per dm cube, 200 grams per dm cube, sorry. 200 grams, sorry, 20 grams per dm cube. That is per liter. It has only 20 grams of nickel chloride we have to add. Next, we add reducing agent, that is sodium hypophosphate. Reducing agent, sodium hypophosphate, which is nothing but NaH2PO2, NaH2PO2. That is 20 grams per dm cube, 20 grams per dm cube. and a complexing agent and a exaltant, which is nothing but 50 grams per dm cube. And a buffer to maintain the pH, it is 4.5 pH we are maintaining. What we are adding is sodium acetate, that is 10 grams per dm cube. What is the temperature we are maintaining? The temperature we are maintaining is 93.93 degrees Celsius. So by adding all these additives, what are the additives? Nickel chloride, sodium hypophosphate, sodium succinate, and sodium acetate. Sodium acetate. So all these after adding into this is the vessel what we are adding in this container. Usually we call it as this is an electrolytic bath or electroless bath containers. In this bath is just a vessel, is just a container where we can place, where we can add all these chemicals or the reagents into this. So before coating the object. So now you take the object, a cathode, dip into this, dip into this. Once you dip into this, what happens? What is the anodic reaction takes place here? The anodic reaction takes place here. Anode means here we are not adding separately anode electron. Anode rods we are not present. What is the anodic reaction takes place here? The hypophosphate ions from the sodium hypophosphate, that is H2PO2 minus ions, react with water, that is the moisture, to give hypophosphite. This is hypophosphate. This is hypophosphite H2PO3 minus. So this forms increases the oxidation state. So here the anodic reaction takes place in the hypophosphate solution, that is sodium hypophosphate solution. What is the cathodic reaction takes place here? Cathodic reaction takes place in the electrolyte. What is the electrolyte? Electrolyte contains nickel chloride. So electrolyte contains nickel chloride means it undergoes cathodic reaction, that is Ni2 plus already is in the oxidation state, which gains the electron. It undergoes to reduction to give nickel. It undergoes reduction to give nickel. So this whatever the nickel liberated here, which is in the bath solution, which is present in this electroless bath container, which will be coated on the surface of a object. So this type of coating is called as electroless plating of nickel. So what is the overall reaction taking place here? The overall reaction take place here, the hypophosphate, that is H2PO2 minus, when it undergoes oxidation to give H2PO3, that is hypophosphite, and nickel under Na2 plus undergoes reduction to give nickel. So what are the applications here? It is used to obtain a wear resistant surface, that means wear and tear resistance, and it is used on a coating of aluminium, improves the solid durability to increase the solid bit, and also nickel coating on polymers. Usually it is done on the polymers to obtain decorative knobs. Decorative purpose also it is being done in a hi-fi equipment and a top on the bottles, etc. So these are the simple applications I am giving here, where and all we can use this coating type of nickel on the surface of a object or a substrate. Understood? So if I want to give an examples means these are all nickel coating which is done by electroless plating process. This is a burnal, this burnal, and this coins, and this one nut, and this is all these bowls. These are all the given examples where it is being used. The electroless plating of nickel is being used for the construction. Can you write down this? Understood or not?
Yes,
Shall I,
ma'am.
shall I repeat once again? You want me to repeat or not required? I'm asking. You want me to repeat or you understood?
No, ma'am. Ma'am, in exam we have to write in same manner. I mean, making chart and all.
Same. Yes, same manner you have to write.
Okay, ma'am.
It is easy so that you will remember what is has to be written. Then what are the reactions also? It is easy to write like a chart. Correct. If it is like a sentences, you will forget.
Okay,
So
ma'am.
write this chart. Write this process. Only write the process of plating bath solution, reducing agent, complexing agent, buffer, temperature, anode, cathode, and overall reaction. Write only this. English class teams has been created.
Yes, ma'am.
Yes, yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am. Create.
Then when it is created, nobody informed me.
Ma'am, 2 to 3 days back, he created the team.
All are there in the English team.
That I don't know, ma'am.
I'm asking everyone. Everyone are there in the class, no? That is why I'm asking. Who is left out? Anybody is not added in the English class team?
Ma'am,
Yes.
ma'am, I have not been added, ma'am.
What's your name?
Meghana.
Meghana. Okay. I'll also inform to sir. You just message me your USN. Okay. After the
Ma'am,
class.
I'm also not
Okay,
added.
ma'am.
Those who are not
Ma'am, I'm
added,
also not on.
for those who have not added, you message me your USN number and request that to add in the English group class team. I'll add to sir. I'll send it to sir. Okay, to add you. All have given the feedback. Nitin, yesterday you reminded
Yes, ma'am. Few of them gave, I guess, ma'am.
what I told you, Nitin. Again, you are saying, I guess, I think. Huh?
Yes, ma'am. They gave feedback and they posted in group also, no, ma'am. Few members.
Only 4 or 5. I want 20 members has to give.
Okay,
Hmm?
ma'am.
What about rest? They should give, no?
Yes,
Those
ma'am.
who have not given the feedback, give the feedback.
Excuse, ma'am.
Yes.
Ma'am, when is our first IA, ma'am?
First day you will get the circular.
Ma'am?
From 28th onwards, you are having a circular. You are having a first IA. Regarding that, circular will be sent to you. As soon as I receive the circular, I will send to you. Okay.
Okay, ma'am. Okay, ma'am.
From 28th onwards, you are first IA. Prepare for first IA portions. 2 modules we are going to complete. 2 modules we are having the for first IA. That I will confirm. But prepare for first IA 2 modules. Complete 2 modules. Written. Finished. Completed. Writing.
Yes, ma'am.
All you have written? Anybody is left out? Writing? Okay, I'll just repeat. So what is electroless plating of nickel means? Electroless plating of nickel is being done without using external power supply. The bath composition is prepared by adding nickel chloride, that is 20 grams per dm cube. Forget about this quantity. If you can remember, you write it. Otherwise, if you write a bath solution contains nickel chloride, that is more than enough. Okay. Nickel chloride 20 grams per dm cube. Reducing agent we are adding, that is sodium hypophosphite, that is NaH2PO2, and complexing agent and exaltants we are adding sodium succinate, that is 15 grams per dm cube. Buffer to maintain the pH 4.5 we are adding sodium acetate, that is 10 grams per dm cube. Temperature we are maintaining for the coating of nickel is 93 degrees Celsius. What is the, after adding all these reagents into the vessel, into the container, the bath solution is prepared. From this bath solution, what is the anodic reaction takes place is, from hypophosphate to hypophosphite solute, it undergoes oxidation in an anode, and in the cathode, from the nickel chloride Ni2 plus reaction, Na2 plus, it undergoes a reduction to give Ni. What is the overall reaction is, hypophosphite undergoes oxidation, nickel undergoes reduction to give metal ion nickel. So this metal reduced nickel coated on the surface of a object, coated on the surface of a object. This is how electroless plating of nickel is being done. So the next what you have is, any doubt here? I'll go to the next. So the next is electroless plating of copper. What happened to this? Electroless plating of copper means, have you seen the printed circuit boards? How many of you have seen the printed circuit boards? PCBs. How many of you seen the PCBs, printed circuit boards? Have you heard of this name, PCB? Raise your hand. Yes. On two, only two. Only two raised hands. Others, three. What about others? Four. Only four known about printed circuit boards. Others doesn't know. I'll show you what are printed circuit boards and where it is used. These printed circuit boards are prepared. These printed circuit boards are prepared by using this electroless plating of copper process. This electroless plating of copper process, before going to this, I'll just, yes, okay. The printed circuit boards, somewhere I have shown one pic, no? That printed circuit boards. I think in the beginning, correct? Yes, here there are some boards, you see. These are all printed. Here there are some boards. See, these boards are circuit boards, and these boards also, here are some boards are there. These are all printed circuit boards. These are all boards are prepared by, are done by using electroless plating process of copper. One example, I'll just show you how it looks like. So how it is being done? What is this printed circuit boards is being done? First, you have to pre-prepare electroless plating. You have to pre uh, you have to pre-activate the surface. The surface to be coated is first. The surface is to be coated is first is degreased by organic solvents. Sorry, by organic solvents. These organic solvents are alkali, followed by acid treatment. Followed by acid treatments. Metals like iron, cobalt, nickel, etc. do not need pre-treatment. and non-metallics like glass, plastics, printed circuit boards, PCBs are activated first by dipping in stannous chloride or HCl solution, followed by dipping in palladium chloride solution and dried. So what it means? It means that you before coating of copper, before copper coating on the surface of a object, you should see what type of object it is, whether they are metals like iron, cobalt or nickel, or they are non-metals like plastics, PCBs or a glass. So you should see whether what type of object it is, whether it is metals or non-metals. If it is a metals like iron, cobalt and nickel, you have to do a pre-treatment. What is that pre-treatment is? Pre-treatment is nothing but you have to degrease, remove the grease and remove the oil and impurities by treating, by immersing or by passing into acid solutions and alkali solutions. Once this is pre-treatment is done, that sheets are ready for coating. If they are non-metal materials like plastics, printed circuit boards, PCBs, glass, that doesn't require a pre-treatment because it is ready to use, because they are not used a grease and all. So this can be activated. This has to be activated first by immersing. First it has to be activated by immersing in or by dipping in the solution of stannous chloride, any concentration, or HCl's hydrochloric acid solution, and followed by palladium chloride solution. But just by immersing in or just by dipping in this type of solution, the non-metals get activated. So this is the free treatment process for the object. Once the free treatment is done, this object is ready for coating. Use that object and prepare the bath solution. How to prepare the bath solution? What is the coating solution? Coating solution we are using, because this is electroless plating of copper, we have to coat the copper. So hence the bath solution we are preparing by using copper sulfate solution. What is the quantity? How much concentration? 30 grams per dm cube. So what is the reducing agent we are adding? The reducing agent we are adding is formaldehyde, which is 37% solution, 170 ml per dm cube. That is reducing agent. What is the buffer you are adding? Buffer to maintain the pH you are adding. To maintain the pH buffer you are adding NaOH. That is sodium hydroxide you are adding and Rockel salt. So Rachel salt or a sodium hydroxide together acts as a buffer to maintain the pH. So what is the pH is maintained? In the bath solution, the pH maintained is 11. So what is the complexing agent or exaltant we are adding? We are adding EDTA, that is 70 grams per liter. Based on this quantity concentration, you can add EDTA. So these are the reagents for preparation of bath solution. What is that? Coating solution copper sulfate, reducing agent formaldehyde, buffer is NaOH or alkyl salt, complexing agent or exaltant is EDTA, pH is to be maintained at 11 and a temperature maintained is 25 degrees Celsius. What is the reaction takes place here? Reaction takes place here because reducing agent we are using formaldehyde. Formaldehyde undergoes reduction or oxidation to give formic acid. So this formaldehyde, there it is one pointer. Okay. This formaldehyde react with hydroxyl ions from NaOH, that is from alkali, undergoes oxidation in the anode to give formic acid, that is HCOO minus formate ion. So this, after forming this HCOO minus ion, this is a unstable compound. So this unstable compound liberates along with the electrons. Whatever the electrons liberate here, it gained by the cathode, which is the copper, which is already in the reduced state. Sorry, it is already in the oxidized state. That is Cu2 plus, which gains the electrons to give Cu, that is copper. So once the copper is liberated here, this copper is coated on the surface of a object. So once this reactions takes place only in the bath solutions after adding reducing agent, after adding buffer, after adding complexing agents. So this is how the reaction takes place. How this copper coated on the surface, say for example, we have taken one plastic and activated by immersing in stannous chloride and just coated with done, that is ready for next coating. This is the rod. What you are seeing, this is the rod. See, this is the one plastic. This is one, what you can see in the left hand side. You can see here. Can you see here these lines? These lines are first one is the plastic, middle one two lines are the plastic board. Above that a coat of copper foil is been coated. This is one coat of copper foil. I've shown here in the arrow mark, copper foil, insulating base and the copper foil. That means a plastic board is covered by a copper foil and the copper foil. So the next what happens? Etching the copper to promote the tracking. One second. I'll just try to open this board. This will not open. So uh, this insulating base, a copper foil which is here. This is also a copper foil. Between that copper foil, a insulating base, that is nothing but a plastic glass or anything is been taken as a insulating base. So what is been done? Etching next some of the drill some place here. Here make a terminal, drill it and etch that surface. Etching means taken out, take out the surface. It becomes like a hole. You can see there is a hole here, which is a etching of copper to produce a tracking. This is also hole. At mark two markings, make is a two marking and dig that surface, remove that copper foil surface at the two ends. When you remove that copper foil surface at the two ends, what happens? So here etching, after etching, this insulating copper, this acts as a terminal. What happens? This acts as a terminals. One is anode terminal, another one is a negative terminal. Now what happens? Now you have to drill. I am explaining the process of how PCBs are being our PCBs are being done by coating with the copper. First, you have to activate. This is the plastic insulating base. It has to be activated by one time immersing in the bath solution of copper. After one time immerse in the bath solution of the copper, this happens. Okay. After that, you have to drill the surface. Drill the surface means here. See, one. I'll just show you. This is the plastic. After plastic is been done, you have to coat with the copper. See, you have coated with the copper, so it looks like this. On the surface of a plastic, it has been covered. Now what you have to do? Now you have to take a drill and mark somewhere and etch that surface and take out. Now, once you take out, it becomes a mark like this. A hole will become, it develops one uh, terminals. One terminal means here one terminal acts as a negative, here one terminal acts as a positive. So now in between these two terminals, you drill the surface and cut into two half. Two half means it separates into two half boards. Okay, two half boards it separates with the hole what you have done and etched the surface you have taken out. After that, along with the coil, can you see here? I'll just trying to make, here also copper is present, here also copper is present, here also copper is present, here also copper present, but there is no copper present here in the surface. Hole here is not there, here it is not there. Now, after this, again you immerse this surface into the bath solution. Once you immerse this into the bath solution, what happens? Again, this doubly coated, this is already one coated, now you have to coat. Now one again, if you immerse into the solution, what happens? Again it will coat onto the surface like coated, double coated. Once it is double coated with the covers with all holes, whatever etched surface are present, covers the copper. This is doubly coated, double coated copper with the electrolytic bath solution. So this copper coated on the surface without electric current is called as electroless plating of pearl. Such type of preparing double coated copper surfaces act as conductors, that act as conductors. Before plastic is semiconductor, before plastic is what? They are insulators that will not conduct the electricity, correct? They are insulators. Once it is coated with the copper and it contains the terminal, it acts as a conductors. Now it can be used to conduct the electrons. These PCBs are generated by doubly coated or double coated by drilling and just by immersing in the bath solution. So this is a simple process. First take the insulate base, immerse in the bath solution, which contains what? Which contains copper sulfate, formaldehyde, and what is that? Buffer solution, sodium hydroxide, EDTA, and all these things. So buffer solution, EDTA, everything, Rockwell salt is present. You must take that insulate base, that is plastic or glass, everything, immerse in this bath solution. It will be coated. It forms the first one. This is the first one. After that, what happens? It becomes the second one. Little h, you etch that and remove it. Again, you immerse in the same bath solution. Activate the surface. Again, it will coat with the other surface of the other coat of the copper. This is a simple process of how PCBs are being doubly coated. For PCBs with the double-sided circuits, though hole connection is required, the through-hole connection is made by electroless plating technique, which does not require electricity. So to start with, the two sides of plastic can be used. Plastic board can be electroplated. After electroplating this, it can be used in the conductor. It can be used as a conductor. Main application is this is converting non-conductors or insulators into conductors. The advantage of this electroless plating over electroplating is electroplating process only activated metals can be coated, but here conductors, non-conductors, insulators also can be coated and it can be converted into conductors. So what are the main differences between electroplating and electroless plating is electroplating is a driving process. We require a power supply, whereas automatic sorry, it electroless plating, it is only catalytic redox reaction. Here anode undergoes, that is a metal undergoes metal oxidation, but whereas here in electroless plating, reducing agent here, reducing agent undergoes reducing agent to give oxidized product. The difference between the anode reactions here, the difference between the cathode reactions here is both are same. Metal undergoes reduction to give metal, reduced state of differ in the anode reaction. And what is the site of anode reaction? Separate anode is required in the separate anode is required in the electroplating. Here article, whatever the article you have to plate, that you have to require in the right site of the reaction. The cathode here is activated article. Article is nothing but object. What you have to plate, that you have to take as cathode. Here also the cathode is with catalytic surface, that means activated surface you are taking. What is the anode reactant here? Metal or water in the electroplating process. In electroless plating process, anode reactant is reducing agent. What is the reducing nature of the deposit here? The nature of the deposit here, pure metal or definite alloy. The nature of the metal examined with reducing agent or derived species. This difference, whatever I am showing the difference between electroplating and electroless plating, Definitely there will be a question. It will be asked for 6 marks definitely. Max to max 8 marks. 8 marks question very hard, but 6 marks definitely you will get in this difference. Differences between electroplating and electroless plating. Understood? Taitenro, students, understood or not? Write this. Write these reactions. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ನನಗೆ ಡೌಟ್ ಬರುತ್ತೆ ನೀವು ಮಾತಾಡದೇ ಇದ್ರೆ.
Yes, ma'am. Understand.
Yes.
How many can listen? Understanding or not? Write this. After writing this, you tell me. Shall I take the attendance? Yes, Pushkar, now you ask me your doubt. You are there, Pushkar, or not? Stepped. Pushkar, I think it is not. You don't have
Yes,
any
ma'am.
doubt. You don't have any doubt.
Till now, I am understanding.
No, you asked some doubt in the beginning of the class. No,
Acha,
that's
yes, ma'am. In assignment, in question number 6, ma'am.
read out that question
Yes, ma'am. Just a minute.
because I have to open the assignment and see what is that. Others write down that reactions. Can you able to see or not? ಕಾಣಿಸ್ತಾ ಇದೆಯನ್ರೋ?
Yes, ma'am.
Yes, ma'am. The last question is that we have to write the type of corrosion and explain. And the first one is, ma'am, bolt and nuts by the different metals partially filled iron water for the long time, and the part of nail inside the wall.
Yes. What
Ma'am,
doubt
so
there?
in third question, ma'am, part of nail inside the wall.
You have to identify what is that type of the corrosion. Correct? How much it is partially immersed metal.
Mm-hmm.
Partially immersed metal. What happened here? A partially nail is immersed inside the wall. That means only air gap, low air gap is present, right? That means it
Yes,
is
ma'am.
what is that identify the type of corrosion means you have to identify first what type of corrosion, partially immersed metal and comes under differential aeration corrosion. So this type
Yes.
is first one is the type of corrosion involved here is differential aeration corrosion. So what is the differential aeration corrosion? You have to explain. And while explaining, like partly nail is immersed inside the wall, hence whatever the halfly immersed inside the wall, it acts as an anode and exposed portion acts as a cathode. The one portion acts as a anode, undergoes anodic reaction, which is an oxidation, and the next exposed portion undergoes reduction, which is a that is OH minus ion liberation, and that reactions you have to write for both, and you have to explain. Understood?
Okay, ma'am.
Like that they will not ask you directly to write differential aeration or differential metal. You have to identify, you have to write the diagram, and you have to explain with the reactions you have to explain. And one more thing is that dust particle sits on the surface of a metal for a longer period. What type of corrosion? What type of corrosion? Identify the corrosion type. If a dust particle sits on the surface of a metal for a longer period of time, it comes under what type of corrosion? What type?
Pitting corrosion.
Huh?
Pitting corrosion.
Yes, pitting corrosion. You have to explain their pitting corrosion. Under that pitting corrosion, you have to, it also comes under differential aeration corrosion, like that. Identification, explanation, and writing the reaction carries the marks. Okay. Next, I'll give you one more example. Halfly filled tank. Half filled water in the tank, steel tank. What type of corrosion? What type of corrosion? Half filled water in the tank. Girls, nobody answering. Pushkar, you understood the concept or not?
Yes, ma'am, got it.
Now tell me, what is this type? Half filled tank. What type
And
of corrosion?
waterline corrosion.
Yes, waterline corrosion. Okay, like this you have to identify and write the explanation. Is there any
Okay, ma'am.
other doubts in
No, ma'am.
this corrosion chapter? Like in the assignment? So this completes 2 modules. By this electrolysis plating of copper and electrolysis plating of nickel. So these 2 modules prepare for your test, IA test. And when I told you that I will give you a test, unit test 2. When? Which date?
Friday, ma'am.
Ma'am, Friday you said, ma'am.
Friday. Okay, Friday. Friday you have lab, no? One batch have lab in the morning,
Yes,
correct?
ma'am.
Okay, Friday only you can write. No issues. Fine. Shall I end this one? I downloaded any doubts you have in this class. Read properly. Notes have been uploaded in the MS Team. Download the notes and read properly. Read for IA, study for IA. Yeah, you can leave the class. Yes,
Thank you,
Pranav
ma'am.
Swaroop, you raised your hand. Anything you want to ask? Pranav Swaroop.